Good evening, everybody, and welcome to tonight's edition of the Triangle Area SQL Server User Group's Data Science and Business Intelligence meeting. Tonight, we have the pleasure of having Sanil Mhatre talk to us about topic modeling. So this will be a very interesting topic in the data science space, and with that, I am going to hand it right over to Sanil, so please take it away.
Thank you so much for that quick introduction, Kevin. This is my second time speaking with the Triangle Area user group, and I'm really excited that you guys would like to have me back and present this brand new session that I came up with earlier this year while my baby was about 1 month old, and I was like out of my mind. Just doing diaper change and feeding, and wanted to do something creative in addition to baby care. So bear with me, there might be some rough edges during this presentation, and I'm hoping for your feedback to polish off some of the rough edges. So as Kevin mentioned, the topic for today's session is topic modeling, a deep dive into text analytics, or what we commonly also refer to as natural language processing. I'm Sanil Mhatre. I'm the lead data scientist at Worldwide Technology. We are a manufacturing and technology services and consulting company headquartered in St. Louis, Missouri. Fun fact about me, I live off of an island. I live on an island off of the west coast of British Columbia, Canada, and have been working remotely about a couple of years before the pandemic started. I am a data scientist with an extensive background in data engineering, business intelligence, database administration, and enterprise architecture. I have worked with Azure, AWS, and Google Cloud Platform. I have worked with SQL Server, Oracle, yes, I said Oracle, Snowflake, PostgreSQL, and MongoDB. And outside of the core technical platforms and tools, I also love working as an Agile coach, a mentor for STEM students, and I like to speak, blog, and volunteer in the community. You can find me on LinkedIn and Twitter. I also publish articles on Redgate Simple Talk, including an article about the very topic that we are about to deep dive into today. So let's jump right into the agenda for today. We have four high level topics to cover today. First up is introduction to topic modeling. We'll talk about what is topic modeling, why do you want to use topic modeling, what are its benefits, where would you end up using the technique of topic modeling, and how do you go about at a high level performing the process of topic modeling. Next, we'll deep dive into the data prep needed to perform topic modeling. This is where we'll crack open a demo, a real life use case, and we'll go through the rest of the agenda using this real life demo. We'll look at the exercise of model training and evaluation. And lastly, we'll also look at how do you infer some meaningful insights from the topics that the topic modeling algorithm spits out. So let's start our introduction to topic modeling with a brief overview of the landscape of natural language processing. Natural language processing is a machine learning driven process for deciphering text data and human language using software. There are a few broad categories of machine learning algorithms under the umbrella of natural language processing. There's sentiment analysis, named entity recognition, text summarization, aspect mining, and finally, last but not the least, topic modeling. That's the area of focus for today. Uh, I'm not going to go much into the details of what the other techniques are in the interest of time. But if you folks remember my previous session at your user group, we talked about sentiment analysis. which is the first bullet point here. So today we are going all the way to the other end of the spectrum and we're going to talk about topic modeling. Topic modeling is an unsupervised machine learning technique. Most folks may have heard of two broad categories of machine learning: supervised machine learning and unsupervised machine learning. My favorite example of supervised machine learning is teaching a machine learning model to recognize pictures of kittens. We all love kittens, right? I have spent too many hours looking at cute kitten videos online. That's most of my Twitter feed, kitten videos and puppy videos. But I digress. If you want to teach a machine learning model to identify the picture of a kitten, you can train that machine learning model by showing it hundreds and thousands of pictures of kitten. We show it a big kitten, a small kitten, um, a brown kitten, a black kitten, a kitten standing up, a kitten sitting down, a kitten taking a nap, a kitten eating its meal, all kinds of different things. And every time you show the machine learning model the picture of a kitten, you tell the machine learning model, this is a kitten. Over time, the machine learning model will learn to detect some patterns and it will slowly start recognizing the picture of a kitten on its own. That's supervised learning. You're teaching the machine learning model by supervising its learning process. Topic modeling falls into the other category, unsupervised learning, where you don't really supervise the activity of training the model. Sometimes this is the only technique you can rely on because you don't really know what you're looking for. And topic modeling truly falls under the category of you don't really know what you're looking for, so let's use some machine learning techniques to discover it. This will become a lot more clearer as we jump into some details of what exactly it is. So bear with me for now. Just keep in mind that it's an unsupervised machine learning technique that you use to discover which topics exist in your body of text. Kind of think of it like clustering algorithms. K-means clustering is a good analogy. You don't know how many clusters you're looking for. What do the clusters mean? You run your data through the model and let the model tell you how many clusters exist in your data set. Kind of like that. So, at a high level, the topic modeling algorithm represents any text document as a collection of topics. Think of it like a book. A book has chapters. Similar analogy, a text document is simply a collection of topics. The topic modeling algorithm will find relationships amongst various data points in these collections of text documents. The specific topic modeling algorithm that we are going to look into today is called Latent Dialect Allocation. It's a probabilistic modeling technique, and it goes a little bit farther into specifying the generic definition of a topic modeling algorithm. It not only treats the document as a distribution of topics and a topic as a collection of words, but it's also aware of the frequency. What I mean by frequency will get a little bit clearer over the next couple of slides. This is a visual representation at a 10,000-foot level. How does the LDA algorithm work? On the left-hand side, you feed a collection of text documents to the LDA algorithm. The LDA algorithm is going to tokenize the text, meaning it will break down that text documents into its components, basically words for the most part, but that can be unigram is one word, bigram, true words, or trigrams, three words. Um, it will shake all of these tokens together and then it will try to identify the broad topics that exist in this collection of tokens that it has. So the colored circles up there, the red one, the blue one, and the yellow one, let's say that the topic modeling algorithm has found that there are these three topics that are represented by the three big circles. But what really are topics? Topics are basically just a collection of words, a cluster of words that appear closely together. So the gray dots within every circle represent the words that come together as a cluster to create a topic. So just a summary of what we talked about in the previous slide in a pictorial form. The topic modeling algorithm is going to treat your document as a collection of topic and every topic as a collection of word. And it's going to also know what is the frequency of every word within every topic, the distribution. I'll take a quick pause here to see if there are any questions before we move on to talk about what are the situations where you might find topic modeling useful.
So there aren't any questions yet, but if you do have questions for Sanil, please get them in the chat and I will be sure to pass them along.
Sounds good. Thank you, Kevin. And as Kevin said, please feel free to post your questions in the chat. I'd love an interactive audience. I'd love the engagement in a session rather than just me talking at you. I would love for this to be a dialogue, for this to be a conversational session. All right, so let's try to understand what situations would you find topic modeling really useful in? Why would you use topic modeling? It's a lot more fun to learn about something if you know how to use it, right? So let's talk about that. Let's say that you have a customer complaints database. Maybe you're operating a call center, and the call center is recording and transcribing all of the customer calls and storing that text in a database. Maybe you also have a chatbot and a chat-based customer support feature, and all of those chat logs are also stored in this customer complaint database. Now, your executives are probably wondering, why do we have such high call volumes? Why is our call center always busy? Let's find out what are our customers really complaining about. Those are the kind of questions that topic modeling really shines at answering. You could run the topic modeling algorithm on this customer complaints database, which has the chat text and the call transcript, and probably come up with the top 5 complaints that your customers have about the application, the product, or the service that your company is supporting. Another example is survey text. This is a very, very popular and real life example in my company. Uh, you folks may have heard of Great Places to Work survey, Great Places to Work awards. My company has been winning the Great Places to Work award for the last 10 years in a row, and my team is responsible for providing analysis for the survey data that comes back after the survey has closed. That survey asks a few open ended questions as well. And 5,000 plus people from our company have responded to that survey in the past. And it's pretty tedious to read each and every text response and try to identify some trends, try to identify general themes out of those text survey responses. We use it quite heavily for survey analysis, not only for Great Places to Work survey, but various surveys that our company administers. I'll also be talking about the demo at the right time, probably in a couple of slides from now. So, uh, there is a need out there for getting meaningful and actionable insights from text data. Not all text data might lead to actionable insights, but typically text data related to customer complaints, reviews, feedback, um, Yelp reviews, for example, Google reviews, tweets, Facebook posts, survey responses, they might have some insights hidden in them that your company might benefit from acting upon. Topic modeling is really useful over there. There are some limitations to the other techniques we talked about previously, like sentiment analysis, text summarization, aspect mining, keyword and key phrase frequency techniques. Topic modeling overcomes most of these limitations of the previous techniques we talked about. Topic modeling is also relatively easy, it's pretty reliable, and it's a popular technique, so there's a lot of help and support available for this online. And then we also talked about the fact that you can discover valuable business insights by applying topic modeling algorithms on top of certain types of data sets. So that's where topic modeling is really useful. And hopefully, this puts some context around why would it be fun to learn about topic modeling over the next few minutes. All right. So now that we have addressed the big W question, the why should we be interested in topic modeling, let's talk about at a high level what does the topic modeling process look like? Like all data related processes, you start with loading and cleaning your data. You then perform something called tokenization, which is breaking your text into individual components that machine learning algorithms can operate upon. You then eliminate stop words, you create engrams, and you also perform something called lemmatization. Uh, don't worry about trying to understand in too much detail what each and every one of these steps mean at this point. Uh, in the subsequent slides, we will cover those steps in detail, but I do want to give everyone a roadmap of what to expect so that when we look at the code, you might be able to put some context around where in the whole process does this piece of code lie. So once you have removed stop words, generated n-grams, and done something called lemmatization, then you create a dictionary and you create a term document frequency corpus. Next, you begin the training process for the topic modeling algorithm. This step happens iteratively, where you build an LDA model, you perform the you look at the model performance metrics, and then you look at the output of the model. The output of the model that we will be looking at for the purpose of human interpretation is called the Entertopic Distance Map. And you perform these steps iteratively until you're happy with the output of the model. Once you're satisfied that the model is behaving appropriately, is performing up to your expectations, you finalize that model, and then comes the very, very interesting step of interpreting the output of the model in a human readable format. This is where it's a bit of an art, not just science, and your subject matter knowledge as a human comes into picture. Your expertise as a human comes into picture to label the topics into something that makes sense to us humans. So that's the high level process. Next, we'll jump into uh, talking about the demo use case.
As you get into that,
Quick pause here.
oh yeah, actually, there's a question in here about the term document frequency corpus, so what is TDF? Is that something you're going to dive into further?
Yes, there is a slide as well as some code that demonstrates the term document frequency corpus. So we will deep dive into that in a few minutes.
Perfect. Thank you. And that was the only
Uh,
question so far.
awesome. All right, then. Let's talk about the demo use case. My company runs our IT department in an agile fashion. We have 9 IT teams, and every quarter, our agile office sends out an open-ended survey or a survey to all the IT teams, which just has one open-ended question that helps assess the health of the team. They simply ask the team members to answer the one question: how do you feel about your team's health in this last quarter? That's it. You're free to answer in whatever way you like. Uh, Folks from last year might remember this is the exact same demo data that we had for the sentiment analysis use case as well. So I'm using the same data. This is real life data from my organization. It's just de-identified, and all of the proprietary information, all of the privacy details have been scrubbed out, and otherwise it's real life data. This dataset has responses from 9 teams, rolling up to 3 managers, and the surveys have been administered over a duration of 4 quarters. There are 300 responses, and they are available in an Excel file. So I'll switch over to the Excel document real quick. You have 4 fields in the Excel file: year, which just has the year and the quarter. You have the manager. I have de-identified that as manager 1, 2, 3, 4, hidden the names of the managers. Then you have the team name. I have de-identified that as well, team 1, 2, 3, 4, 5. And then the response field. You might notice some people are pretty verbose with the responses. Like this one seems to have at least 4 or 5 lines. Whereas line number 7, this individual has responded with just one word: solid. So there's a variety of way that people can respond to open-ended questions. And let's dig into this demo now. I'll briefly talk about the demo environment. I won't really go into the details of installing some of these packages in the interest of time. The demo environment that I'm using is built on Anaconda Personal Edition, installed on my laptop. I'm using a Windows laptop. Uh, I spin up a Jupyter notebook, and I'm using Python for this exercise. I'm using a package called Spacey for lemmatization, NLTK for stop words, Gensim for topic modeling, PyLDAViz for the interactive web-based visualization called the Entertopic Distance Map. This is the key visualization we'll use to determine if our model is good and to interpret the topics that exist in our model. And lastly, we use some of the standard Python libraries like pandas, numpy, matplotlib, and Workload. The first thing we'll do is create a workload after we ingest the data. So I'll now switch over to the demo. What you see on my screen is the Anaconda Navigator homepage. Once you launch Anaconda Navigator, I have simply clicked on the launch button for Jupyter Notebook. This opened up in a browser for me. A screen like this will open up in your browser when you click on a Jupyter Notebook. I already have a Jupyter Notebook ready in my folder called Topic Modeling Conference Sessions, Topic Modeling dash copy one, Jupyter Notebook. So I clicked on it and it would open this Jupyter Notebook. The first thing I'm doing is installing a specific version of Jensen, version 3.8.3, because some of the wrappers that I'm using uh, were deprecated in the 4.0 release. So my demo wouldn't work really well if I install the latest release of Jensen. So I'm using this particular release of Jensen. This might take a few seconds to finish, shouldn't be too long. It's finished. It basically validated that everything is already installed. Next, I'm installing, shouldn't say installing, I'm importing the libraries that are commonly used here. So we talked about NumPy, Pandas, Gensim, Spacey, PyLDAViz, things like that. So let's run this cell of my Jupyter notebook, and looks like it is complete. I'm going to just browse towards the right side to see, yep, it is complete. So we can move on to the next cell for reading the Excel file into a data frame and performing some basic cleaning. So I'm reading the Excel file into a pandas data frame using the simple read Excel method. I only care about what the one column that has the text response. So I'm only filtering my data frame to keep that one column. Then I'm converting everything to a string, converting everything to a lowercase, and then I'm removing all the non-alphabet characters. I'm removing numbers, punctuations, everything else that is not an alphabet. So let's run some of these basic transformation steps, and you'll see the top 10 rows of the data frame before we apply transformation. It has the same 4 columns that the Excel spreadsheet had. And then the next 10 rows are after we have applied the transformations. Now, this data frame only has one column, the response text. You'll also notice that the numbers are gone, the exclamation points are gone, some of the punctuations like commas, period, all of those things are now gone. And we only have the alphabets. That's what we care that's what we care about. So at this point, I'm going to create a word cloud. A word cloud is a pretty popular visual. In my opinion, while it's very, very popular, it's also kind of limited in its usefulness. So the word cloud is basically going to look at all of the tokens, all of the words in your text, and it's going to plot a frequency map of that text, where the size of the word represents its frequency. So the word together is largest on this word cloud. It means that the word together was the most frequently occurring word in this body of text. Then you probably have words like team, works, well, and fun that show up as large words, not as large as together, but they still are prominent. And it's kind of difficult to interpret a lot of meaningful insights from this word cloud. I only get a sense that things are going well. I only get a general positive sense by looking at this word cloud about the health of the teams. Nothing concrete, nothing specific. Let's put a pin in this, and we will revisit this at the end of the topic modeling exercise and compare how Topic modeling outputs are a lot more insightful than the word cloud, and how it's worth investing the time and effort into doing topic modeling to get those deeper insights.
By the way, would it be possible to bump up the font size just a little bit further?
Yeah, sure. Let's see, Control plus. How about now?
I think it should be good. If I get any more mentions in chat about it, I'll ask again. But I think that should be good enough. Thank you.
Thank you, Kevin. This is always tricky with webinars, because in a live session, uh, someone from the back of the room will yell, "Hey, it's too small." So here I'm depending on someone to figuratively yell and let me know when things aren't going well. So thank you for moderating that, Kevin. All right, let's switch back to our slide deck, and we'll briefly talk about tokenization and stop words, and then we'll look at the code that deals with tokenization and stop words. I'll also probably cover engrams and lemmatization at the same time, and then we'll go into the demo altogether. So, tokenization is the process of separating your body of text into smaller units called tokens so that natural language processing techniques can be applied on top of it. That's just the way most of the NLP algorithms are written. They need your text to be broken down into smaller units so that the algorithms can be applied to it. What exactly do the smaller units look like? These smaller units could be one word each unit. So you can literally break down your body of text into a representation of one word equal to one token. You could also break it down into phrases where maybe the words that occur frequently, like not good, um, something like that, where the words occurring together totally change the meaning. Uh, you might want to look at bigrams or trigrams where three words occur together. So the definition of a token can be as small or as big as your use case demands. Next, we'll talk about stop words. Stop words typically are the most commonly occurring words in the language that don't have a lot of value, that don't have a lot of meaning. So think propositions, think conjunctions, words like a, the, an, or, and. These kind of words are filler words. We use these words very, very often in our text, but they don't necessarily have a lot of meaning, and they can be ignored in your natural language processing techniques without really compromising the overall meaning of the text. So we filter out stop words. Most of the packages will have a predefined list of stop words. We can also customize or extend the list of stop words. Maybe you are dealing with a specialized situation like medical transcripts. You might not want to just depend on the standard list of stop words. You might want to eliminate some of the standard words or maybe make changes to that stop word list. There is the ability to do all of this customization. In our use case, we don't really need it. So we'll just stick with the default stop list. Next, just let's quickly talk about engrams and lemmatization. Uh, Words which make sense individually, just one word, it's called a unigram. When two words come together and make more sense when they come together, they are called bigrams. When a sentence or a phrase is composed of three words, it's called trigrams, and it goes so on and so forth. So it's called engrams. A good example of bigrams would be pretty good or lack of. These two words, when they come together, they make more sense than looking at those words individually. Let's also talk about lemmatization. Lemmatization is simply the process of converting words to their roots. It uses contextual vocabulary and morphological analysis. Uh, it's just a fancy way of saying that it looks at the words that occur before and after the word of interest to figure out the context of that word in the sentence. And it also looks at how the word changes when it's used as maybe a noun versus an adjective versus an adverb versus a verb, or maybe present tense, past tense, future tense. It looks at all of these variations to determine what's the appropriate root of that word. It's typically a much more robust and effective technique than stemming. An example of lemmatization would be if your text has words like walking and walks, plural with an S, walks. After lemmatization, both of these words would be transformed into its root, walk. That's what is necessary for the machine learning algorithm of topic modeling to do its job. We don't really need the noise created by several variations of the word walk. We just need to know its root, walk. So we'll perform these steps in our code. Okay, so the very first thing that I'm doing is tokenizing. So let's run this cell to tokenize. All right, the tokenization step is done. Uh, Next, I am creating four different functions. The first function will remove stop words. So I'm defining the function to remove stop words over here. Next, I'm creating a function to create bigrams, trying to identify two words that come together in a much more meaningful way than just a single word. I'm also defining a function to create trigrams, identifying three words that might come together in a more meaningful way. And then lastly, I'm creating the function for performing lemmatization. After defining all of these functions, let's use these functions to perform the tasks of eliminating stop words, identifying bigrams, and then doing lemmatization. So let's just call our functions over here. I'm only going to stop at bigrams. I'm not going to create trigrams because from trial and error, I know that my code or my body of text doesn't really have any meaningful trigrams in it. This is a little bit of an iterative approach. All right. So I'm running the code now to remove stop words, creating bigrams, and performing lemmatization. Looks like that process is complete. I'm printing sample output over here. Next, we are going to create the dictionary and the document frequency corpus. Before we jump into the code, let's briefly talk about what is that. The topic modeling algorithm requires two inputs in terms of data. It needs a dictionary. The dictionary is simply a collection of lemmatized words from the text. So we talked about the fact that we are eliminating stop words, which means we are eliminating noise. We are creating bigrams. We are transforming words into their roots, so lemmatizing them. Now, the dictionary will be a unique list of all the lemmatized words from your body of text. and a unique ID will be assigned to each and every word. Pretty straightforward. They just like to call it a dictionary. Next is the corpus. The word is simply Latin for body, and it just refers to a collection of text. This is where the corpus that we are creating is a term document frequency corpus. What we mean by that is the dictionary tells us all the unique words that occur in your body of text. The corpus is going to tell us how many times did each and every one of those lemmatized words occur in your body of text, the frequency of their occurrence in the body of text. These two datasets are joined by using the unique ID that was previously created in the dictionary. Most machine learning algorithms like to work with numbers, so the ID comes into play over here. And when I show you the code, I'm going to transform the ID into the word to show you the corpus. Let's go to our Jupyter notebook and look at the code for creating the corpus and the dictionary. Pretty straightforward code, mostly one-liner code. Over here, we are creating the dictionary using the corpora.dictionary method and passing it the lemmatized dataset that we created previously. Next, you are defining the corpus from the lemmatized dataset, and then you are assigning it the term document frequency. These are standard methods. You don't really need to reinvent the wheel and write your own code to perform these functions. Simply use the available methods from the libraries. It makes your life a whole lot easier. The last line of code is simply for printing a set of the corpus in a human readable format. You don't really need this last line of code if you're performing topic modeling. It's just to show us what does the term frequency document corpus looks like. When you print the corpus, you will see the word and its frequency. So the word process seems to have occurred only once. Let's go down and look for a non-one number. The word product has appeared twice. The word scope has also appeared twice. The word vision seems to have appeared twice as well. So this is what the document frequency corpus, the term frequency corpus looks like. Before I move on to the next slide, which talks about using these data inputs to build the topic model, the GenSim model, um, does this answer the question, the previous question about the frequency corpus?
I think
Are
it
there
does.
any follow-up questions?
So I think it does answer that question, although I'll let Mala answer for herself there. Are there any other questions from chat about what we've seen so far before we get into LDA modeling? Mala says yes, that does answer her question, so thank you.
Awesome. So let me switch back to the slide deck real quick, and we'll briefly talk about the theory of building the LDA topic model. I'm using the GenSim library module called LDA model. It takes two inputs in terms of data, the corpus and the dictionary. And we created these two inputs in the previous step. It also takes a parameter as an input called number of topics. This is where, since you, as the user, as the data scientist, don't really know how many topics to expect, the machine learning model also doesn't know how many topics exist in the body of text. So you and the machine learning model are going to perform some iterations to try to figure out how many topics exist in your body of text and what those topics are. And the num topics parameter allows you to iterate over uh, a series of numbers to try to identify the optimal number of topics. The output of the module LDA model is a topic ID, the keywords for each topic, and the importance score for every keyword that represents the topic. So a few slides ago, you might remember I showed a graphical representation of how LDA works. And on the right hand side, we saw some colored circles that represented topics. Think of this output tying back to the big colored circles, the topic ID. Inside every colored circle, we had gray dots. Think of the keywords for each topic as those gray bars. And then lastly, we saw a bar chart that showed how many times a particular word has occurred within that cluster. The importance score can be thought of as a numerical representation of that bar chart. So let's run our code to build our LDA model. We're going to provide the two inputs that we talked about, corpus and dictionary, and then the num topics parameter. And the remaining input parameters, I'm just going to leave default. You don't need to provide these if you just leave them empty. If you end your code after num topics equal to 2, the defaults will take effect. I'm just explicitly calling that out to kind of show what the default values typically look like. I'm going to print the output of the LDA model as a part of this cell. So let's run this cell and let's see what the output looks like. We have asked the LDA model to generate two topics. It's doing exactly that. Topic number 0 and topic number 1. It's giving us the cluster of words that topic number 0 is composed of and the importance of every word within that cluster. You'll see the same thing for the next topic. Topic number 1, the words that the topic is composed of and the importance of each and every term in that topic. And the words are arranged in the decreasing order of importance. This does give us a little bit more insights, but we don't know yet if the model that we have built is a good model or not. This is where metrics come into picture. We are going to compute two metrics to try to evaluate the performance of this topic model. So, what are the two metrics? The first metric is called perplexity. It is a measure of how surprised, how confused, how perplexed your model is when it sees new data that it has never encountered before during training. The lower the value of perplexity, the better your model performs. You want your model to be less perplexed, you want your model to be less confused. The next metric is called topic coherence. The definition of the word coherent uh, comes to mind over here. A set of facts, a set of statements are said to be coherent if they support each other. On similar lines, the metric topic coherence measures the semantic similarity between the various words that form the same topic. So we talked about the fact that how a topic is simply a collection of words. This metric is measuring how similar those words are to each other. If words that are similar to each other are coming together to form a particular topic, that means that the topic makes sense. Higher the value of coherence score, the better is that metric. So, two things to remember: perplexity, the score needs to be lower, and coherence, the score needs to be higher. So, here's the code to calculate these two metrics. Pretty simple code, mostly one-liners. We'll run this cell and calculate the perplexity score and the coherence score. This can sometimes take a few seconds. All right, so we have generated uh, the metrics. We now have these scores. Is this good? Is this bad? We don't know yet because we don't really have a baseline to compare against. So we'll put a pin in this. We will make a note, and I'll make a note on your behalf, and we will revisit these scores as we iterate through the model training exercise. We had also talked about the fact that we want to visualize the outputs of the model using a technique, using a library called PyLDAvis. So that's exactly what we are doing in this cell. We are now going to create a chart called the Entertopic Distance Map that helps us create a visual representation of what does the output of a model that is trained for two topics looks like. So on my screen, you can see the intertopic distance map. These bubbles represent the topic, and on the right hand side, whenever you highlight a particular bubble, the set of words that are highlighted in the red are the words that compose that particular topic. When I click on the circle for topic number one, you'll see on the right hand side, uh, the output is telling me topic number one is 58.2% of the entire body of text. And here are the top 30 terms that come together to form this topic. When you click on the circle for two, you'll see the right hand side has adjusted itself, and you now see 48.1%, sorry, 41.8% of the document is for topic number two, and there is a change in the words that represent topic number two. What you are looking for in an intertopic distance map is that the circles that represent each and every topic are large and spaced far apart from each other. You don't want one large circle and a bunch of really teeny tiny little circles. You also don't want circles that are smushed together, that are touching each other, that are overlapping with each other. As we iterate through model training, we'll see how that helps us identify a good topic model. So let's do that. Let's retrain this model with num topics equal to 3. I have not changed any other inputs. All I have changed is the value for the parameter num topics. It's now 3 instead of 2. Let's run this code and also generate the perplexity score, the coherence score, and the PyLDA visualization of the intertopic distance map. So the perplexity score is ready, the coherence score is ready. I am making a note of what do these scores look like. And now let's look at the intertopic distance map. You'll notice the intertopic distance map looks a bit different. I'm going to zoom out a little bit so that we can see this visual a bit better. You now see there are 3 circles. Circle for topic 1 all the way in the bottom of the screen. The circle for topic 2 on the top left, and the circle for topic 3 on the top right. And the chart on the right hand side is showing us the top terms for each and every one of these topics. Uh, Based on the parameters that we talked about previously, this looks like a good intertopic distance map. The circles are large, the circles are pretty far apart, they are not touching each other, they are not overlapping. We don't have a situation where there is one large circle and a bunch of tiny circles. This looks pretty good. But let's be sure that this really is good, or maybe it might get even better when we ask the model to train itself for 4 topics. So let's run that iteration real quick and see what our outputs look like. All right, the perplexity score is ready. The coherence score has come up. I'm making a note of these scores. And let's look at what does the intertopic distance map look like. Oh, we have a little bit of a no-no situation over here. The circles for topic 1 and 2 are overlapping. This violates our requirement of what a good intertopic distance map should look like. We have circles that are overlapping. What this means is if the model tries to force itself to identify 4 topics from this body of text, it fails at that exercise, and 2 of the 4 topics end up with a significant overlap. This gives us a great deal of confidence in interpreting the fact that this particular body of text seems to have 3 topics. So let's look at all of these things in a summarized fashion. I'll switch over to my slide deck to talk about this summary. All right. So the table at the bottom half of my slide talks about the perplexity score and the coherence score when number of topics is 2, 3, and 4. You'll notice as number of topics has increased, the model perplexity score has decreased. It has become more and more negative. So it's moving in the right direction. The topic coherence score has increased as the number of topics has increased. If you were only looking at these 2 metrics, you might believe that 4 is the ideal number of topics because your metrics are the best when your num topics parameter has the value of 4. So that's where the intertopic distance map really comes into picture and helps you identify that, yeah, while the metrics might show that 4 is the best or the most ideal number of topics from a purely statistical point of view, from a human interpretable topics point of view, 3 is the ideal number of topics. Because after 3, if you go to 4, if you go to the next step of 4, your intertopic distance map starts showing overlapping circles. Make sense so far? I'll take a brief pause here before we jump into the next section, which talks about interpreting the topics, applying labels to the topics.
So if there are any questions from anyone in chat, now's a good time to get them in. One quick question that I have is, are there any maximum bounds for perplexity or coherence? Is it bounded by like 0 to 1 or -1 to -10 or whatever?
That's a good topic, Kevin. I had done some research while creating this talk about the boundaries of these metrics, and I could not find a coherent answer, a consistent and reliable answer uh, to this question, because the same question came to my mind as well. So after a good deal of back and forth and research and talking to various team members who do a lot of natural language processing projects in my company, I decided to not depend on the absolute value of these metrics, but look at them relatively across iterations rather than looking at them from an absolute point of view.
Okay, yeah, that makes a lot of sense. And also, I can see the idea being similar to k-means clustering, where let's figure out where the elbow is. Let's figure out where
Yeah,
that marginal change
yeah,
happens.
yep, you're right, Kevin.
So,
It's very very similar, uh, or it's very analogous to how clustering works.
okay, cool. Looks like there are no questions in chat at the moment.
All right. Let's talk next about inferring the topic labels from the topics that we have identified. So, through this exercise that we went through so far, we were able to discover, we were able to conclude, we were able to come to the realization that our body of text has three topics. Let's find out what those topics are. This is where it's a little bit of an art rather than a science. So you simply click on the circle for topic number one, and the bar chart is going to show you the most frequently occurring terms for that topic. You make a note of the top 10 terms. You do something similar for topic number two, and you do something similar for topic number three. And then you apply your subject matter expertise, your knowledge of the use case at hand, your expertise as a human. So, when I look at the words for topic number one, uh, the top 10 terms for topic number one make me think of a sentence that I could potentially create using those words. Think of it like Scrabble, but you're working with words rather than working with individual letters. So the sentence that I was able to create with some fill in the blanks is the overall team health feels good, positive, green. Uh, the words that are inside brackets are my own fill in the blanks to help formulate a meaningful sentence. The words not in the brackets are the ones that came out of the topic modeling exercise. I apply some similar human magic to the words that come together for the second topic, and a sentence that I can create out of it is great work, good support, a lot of fun. The last topic, the third topic, looking at the words, uh, I'm able to create a sentence that looks like room for improvement. And every time I'm creating a sentence, I'm eliminating some of the words that were in the previous topic to keep the next topic as distinct as possible from the previous topic. So you'll see the word team has come across in each and every one of these topics. Uh, the word good has come across in each and every one of these topics. Once you have used that word for a particular topic, you consciously try to avoid using that same word for the next topic as much as possible. So let's now compare this outcome against the word cloud. We saw the word cloud towards the beginning of our demo, and that's what I have on the left side of my slide. The word cloud visual helps us identify that the word together is the most frequent word, followed by works, fun, well, and team. These terms have a general positive connotation, but not really much more deeper insights to be gained. On the right hand side, we have the output of topic modeling, and I see a typo that I need to fix. Uh, Topic modeling, not topic modeling. Uh, Topic number one, two, three, and I am now applying some of my business context knowledge uh, to share these insights with my pretend business stakeholders, which are not really pretend in this case. Every quarter, I present this analysis to our IT leadership group. So, looking at the topic modeling output, the analysis that I can present to our IT leadership group this time seems to be that the prevalent consensus, so 43.3% of the survey respondents, seem to indicate that the overall team health is good. It's overall positive. The second topic, which is about 37%, the way I can present that summary to the IT leadership group, my stakeholder, would be about a third of the survey response seem to indicate that the teams are supportive of their team members, and the team members seem to have a lot of fun. Work is great. So, overall, there is a positive work environment in the team. And then the third topic, which is about 20%, I can convey that, I can summarize that to my business stakeholder group, the IT leadership team, is about a fifth of the survey responses seem to indicate that while things are mostly positive, while most of the teams feel that their health is good, there seems to be some room for improvement. There seems to be some grumbling, some complaining, some unhappiness, where folks might want to work upon opportunities for improvement. What exactly are those opportunities for improvement? We might be able to get clarity on that if we perform topic modeling at the team level. I'm not really going to do that here for the purpose of the demo, but this is what I do in real life at my organization as well. Once we have this executive summary for all IT teams, we then break it down into topic modeling for each and every team. And that sometimes gives us interesting insights about what is it that people are complaining about, what is it that people might be unhappy about, what are some of their suggestions for improvements. I'll take a brief pause here if there are any questions or comments about comparing the insights that you can gain from Workload versus the topic modeling exercise on the exact same dataset.
Yeah, so one question that I did have was, and I think I might have an answer, but um, this feels like after you have performed LDA, it may be a good use case for TF-IDF, term frequency inverse document frequency, in order to try to filter out those terms which show up across all of the topics and put bonus on terms that are unique to a single topic. Is that something you've tried out before?
That's That's a great suggestion, Kevin. And I'm actually going to make a note of it because I haven't thought of it so far.
Yeah, I was doing some quick looking while you were talking, and it looks like the answer is TF-IDF is absolutely not necessary, and arguably LDA was created to avoid TF-IDF, but that the outputs could still run through something else um, to emphasize inverse document frequency, just to narrow down so that team which shows up in all three topics
Right.
can be ignored, and you pick out like you're doing here,
Mhm.
finding the things that are more unique.
Right. Right. So the thought process that I'm applying mentally or manually, uh, You're absolutely right. I think TF-IDF could be used to automate some of my manual filtering that I'm doing in my head. Uh, it's probably not an inconvenience when I'm only looking at three topics, but let's say someone is performing LDA on a data set that inherently has 25 topics. Keeping track of it mentally might not be feasible. And you might absolutely need to use TF-IDF on top of the results. Thanks for that, Kevin. That is a wonderful suggestion. I think I have just never had a real life use case for it because, for the most part, our IT leadership uh, is happy with, like, the top three uh, outcomes from the survey or the top five outcomes from feedback. Okay, so the next uh, topic that we'll briefly talk about is automation. We talked about the fact that we iterate through the model training exercise by changing the value of number of topics, starting with two and incrementing it, and then looking at the metrics and looking at the outputs. It can get tedious pretty quickly if your body of text has 20 or 25 topics. It would be super boring to have to do this manually. You could potentially write a program to iterate through num topics, going from 20 to, let's say, 30, 40, 50, and then you can chart the coherence score and the perplexity scores to see how they are trending as your number of topics is increasing. You can also save the PyLDAWS chart for every iteration and review it at the end of the run of the loop. There is a package called LDA Mallet Model. It's an open source toolkit from It's an open source toolkit. Uh, it's provided for helping automate the LDA based topic modeling. GenSim provides a wrapper for using Mallet. This is where uh, I have run into a lot of issues with the versions of Python, the right versions of GenSim, and the right versions of LDA Mallet for everything to work together for this automation. Um, but overall, I'm leaving automation outside of scope of today's discussion, but just making folks aware that you don't necessarily have to do this manually. You can automate it either using the LDA mallet model package or you can program a loop. So with that, we'll wrap up for today with a brief summary of what we covered. We got introduced to the natural language processing technique of topic modeling. We briefly look at the setup of Anaconda Jupyter Notebook environment and the necessary packages for performing topic modeling. We went through the exercise of data cleaning and data preparation steps. We went through the iterative process of training topic model and identifying the optimal solution, identifying the right number of topics in your body of text. We went through the exercise of interpreting human readable insights from the topic modeling outputs, namely the intertopic distance chart. We did a comparison of the insights that you can gain from simpler techniques like Workload versus the more involved techniques like topic modeling. And we talked about how you can gain business value from these powerful techniques compared to some of the simpler techniques. Hopefully, this gives you some material to identify a use case for topic modeling in your environment and um, helps you get started with a project in your own company for natural language processing. Thank you, folks, for your time today. I will stop sharing my screen at this time and ask folks if they have any questions.
All right, anybody, if there are last second questions, let's get them in. If you do have a question and you know you're going to type it out, just post a little thing in chat. Hey, I got a question. And then as you're typing, I'll be sure to vamp for you. But until I know that I need to do some vamping for people, it's going to be a little difficult. In the meantime, what I will say is, Sunil, thank you so much for presenting tonight. I think that was an outstanding introduction to topic modeling and a very interesting discussion of LDA as a technique.
Thank you so much, Kevin. I'm really excited to share this with your group because over the past 2 years, we found quite a few applications of this technique at my company. And typically, I'm not a career speaker, I'm not a career presenter, and I only create sessions when I find something that I'm really excited about and I want to share with the rest of the world. So thank you for the opportunity.
Oh, absolutely. We appreciate it. And it looks like no questions in chat. So, what we'll do is say once again, thank you so much, and we'll wrap it up for the evening. So, remember, everybody, the next meeting is going to be second week of August. We'll do our advanced DBA meeting. Third week, the main meeting. Fourth week, data science, business intelligence. And we'll have a couple shop talk episodes thrown in along the way. All of those details you can find at meetup.com/TRIPASS, meetup.com/TriPass. And with that, once again, Sunil, thank you so much. We appreciate it. And until we talk again, everybody, take care.
Thank you. Bye.